Hello, Kate Graydon. Thank you very much for talking to us on the BeeCraft podcast. Readers will remember you from your fascinating article in the March issue on the variations in honeybee queen egg sizes. You did that as a researcher at the University of Bristol Life Sciences Department, and specifically in the Social Research Insect Lab under the leadership of Christoph Gröter. But today you're speaking to us from Sao Paulo in Brazil. What are you doing there?
Hi, well, thank you for having me on. I am in Ribeirão Preto in Sao Paulo at the moment because I've changed. I'm no longer looking at the honeybee for the next couple months. I've turned my attention to a very small stingless bee called Plebea doriana, and I'm doing some experiments looking at foraging patterns over here. Um, so I should start by saying I'm looking at floral constancy in Plebea in particular.
Floral
And
constancy, what exactly does that mean?
So, floral constancy is a really interesting behavior whereby a bee during a single foraging trip will choose to visit flowers of the same type rather than switching in one foraging trip to visiting different flowers. And this behavior is really important because it means that the bee will essentially carry pollen from one flower to another flower of the same type. Um, and of course, this has significant consequences for the plant because it impacts how much of the right pollen you're receiving, and therefore how likely you are to be able to reproduce and survive. So if you receive a lot of pollen from a flower of a different species, it will just clog your stigma and you won't be able to set seed or produce fruit. Whereas if you receive a lot of pollen from a similar species, the same species, then your reproduction is enhanced by bees foraging. So I'm basically studying how florally constant are plebea, and we know that honeybees are considered almost fully flower constant, whereas bumblebees are roughly 23% flower constant, and stingless bees are somewhere in the middle. They show quite a wide variation, but they tend, on average, to be less flower constant than the honeybee, with an average for a Trigona genus about 77% constant.
Hmm.
Um, but we don't know how florally constant plebea are, so that was my job since I've
Right.
arrived here.
And this has some economic considerations, I would imagine.
Yes, well, plebea are typically pollinators of citrus trees and coffee. So yeah, if you've ever had a cup of Brazilian coffee, you can thank plebea for that. But yeah, plebea is a really important pollinator over here in Brazil.
And apart from the pollination, do they produce honey?
They do produce honey. They produce a very small amount of honey, approximately 35 milliliters per annum per colony, which is very
Wow.
little compared to honeybees, which produce probably 20 to 60 kilograms, I would say.
Right.
Um, but there's quite a lot of variation within stingless bees. I know that the Australian sugar bag bee, Tetragonilla carbonaria, produces about 1 kilogram of honey per colony per year. Um, but plebea is very, very small. So they're only about 2 millimeters big in body size, and there's only a few thousand of them to a colony. So they don't produce as much as other bigger bees.
I'll ask you about the taste later, but sorry for interrupting. Let tell us what your research is actually involved in with the flower constancy.
Perfect. Wow. As I speak to you now, I'm a little bit sunburnt and a little bit tired because we've been essentially training individual plebea bees who are about 2 millimeters big to a site on the campus here at the University of Sao Paulo. And I give the bee, the individual bee, a big dot of paint on her back that's either green or yellow, so I can follow an individual bee. I'll train her to a yellow or blue flower that has a lot of sugar on. And once she's visited 2 or 3 times, and I'm certain that I'm looking at the same bee, when she finally disappears off for the fourth time to put her sugar water back in her colony, in the time that she's gone, I'll switch a table that has just one flower on to a table that has 12 on, which are equally split between blue and yellow flowers. And I basically count how many times she visits a flower that's the same color as the one I trained her to, and how quickly she gets bored and decides, actually, this isn't rewarding me. And I should say the second table doesn't provide her with any sugar solution or any reward. So it's not very long before she gets bored and tries to switch or just leaves the experiment altogether. But we've done nearly 180 bees now, so I feel like I'm probably the world expert on how the Hitleriana forages, because I've just spent 1 month watching them repetitively.
Right. And this nest is in the lab?
So I've actually used several nests across 4 different sites out and about on the campus. So we take the equipment to them, and I'm pretty sure each site, because of the frequency of these nests in the University of Sao Paulo area, I'm sure we're getting 3 or 4 different nests at each site. So we've got a really good sample of the bees on this campus. I wouldn't know how many nests without taking them and genotyping them, but I think it's fair to say at least 4.
So these bees are that common that there's lots of nests around.
There are thousands of stingless bee nests around here, yes. And the popular name for plebea over here is the mirin bee. So even if you talk to, someone on the street or a taxi driver or someone in a cafe, they're all very familiar and very fond of the mirin bee. So
I'm
yes.
imagining these are very small bees. And what's their nest look like? Are they small, and what's their nest look like?
So plebea is absolutely tiny. I think they're one of the smallest stingless bees that we have in Brazil. They're 2 millimeters big each. So if you can imagine trying to put a dot of paint using a
Yeah.
toothpick on the back of a plebea, it's probably the hardest thing I had to get used to doing, more than the scientific data or research. It's just painting such a small bee, and not upsetting her too much. So yeah, they're very,
And
very
in the
tiny.
hot sun.
Yeah, yes. I have to say I've painted a few of their heads accidentally, and then they use their antenna to sort of brush the paint off, and sometimes they end up smearing it all over their eyes, and I think, oh no, not another one. But yes, they are really, really tiny. I'm very, very familiar with them now. And their nests are very tiny as well. So stingless bee nests are a bit different to honeybee nests. In honeybees, as you're familiar with, the brood comb will be vertical, whereas in stingless bees, the brood comb is horizontal. So plebea have a very beautiful stacked brood comb in the middle of the nest. Um, and yes, around the brood comb, they have a little envelope called an involucrum, which is made of cerumen, which is actually a mix of both resin and wax. And that means that stingless bee nests are typically a lot more sturdy and a lot tougher than honeybee nests, which are just made of wax, which makes them quite pliable. But they're very beautiful.
And what sort of size?
So a plebea nest is approximately 200 milliliters. A good frame of reference would be like the size of a cup of tea, a teacup.
Oh, as tiny as that, right? And
Really, really tiny, yes.
and where would they locate them?
So you can find plebea in cracks in the wall, even cracks in trees, in the floor. I've walked around the University of Sao Paulo campus trying to locate them, and they really are everywhere. They find every nook and cranny. So yeah, they're all over here. But in our little managed hive that we have in the Meliponery at the University of Sao Paulo, they exist in a very tiny, probably 200 milliliter box which has the brood comb neatly stacked, and then the involucrum around, and then all the honey pots beautifully laid out around the edges. Um, and yeah,
Is a
they're really
meliponary the equivalent of an apiary for stingless bees?
yes, exactly that. So the Melipona are one tribe of stingless bees, but Meliponini means all of the stingless bees.
Okay.
So a meliponary has all different kinds of stingless bee within there, and they have a lot over here in the University of Sao Paulo.
So they're stingless. Do they have any defense?
Interestingly, yes, they do bite, and I'm aware of one research paper that my supervisor's supervisor was involved in, where he asked a student at the University of Sao Paulo to sacrifice themselves and be bitten by stingless bees and then rate how painful the bites were, which is a completely wild piece of research. But often they won't let go. They would rather lose their own head and become decapitated if you pull on the body than let go of you. So they have a very strong bite and they are unrelenting in this
Oh,
way.
right. So what are their predators?
So my stingless bees, plebea, are predated upon by robber bees, which are their own genus of kleptoparasitic bees. And they are obligate kleptoparasites, so they have to steal honey. They're unable to produce their own, and they find this to be the most beneficial strategy for survival.
Wow.
So my postdoc Tiago is currently mapping all of the plebeian nests that exist within USP, and he's taking a note of every time a Lestramilita lemau, the robber bee, attacks these nests, attempting to create a spatial grid of how close together these attacks are happening and which robber bees are attacking which nests. So he's walking around the campus every day, and when he sees an attack, he's quickly running over, grabbing a net, and swiping up some of the bees to take back to his lab to genotype them and find where the robber bees have come from. And the aim with this is to essentially create a map showing if these robber bees have certain territories. So there's a theory that exists um, where we think that robber bees must be quite evenly spaced, because if too many robber bee attacks were to happen in one place, they would run out of stingless bee nests to rob. Um, and we also think that they must uh, behave in a certain way where they leave their neighbours alone. And this is called the dear neighbour hypothesis. We suspect that they are less attacking of hives nearby their own nest. But all of this is speculation at this point. And once Thiago has done looking at the genotypes and mapping them on the campus, we'll have a better idea of how Lestramilita lemau attack bees and whether they have certain territories that they stick to, which is going to be really cool.
Yeah, absolutely fascinating. So these kleptomaniacs, do the public know about them, and are they targeted?
So the public definitely do know about them in indigenous communities, where stingless bee honey is really important for a range of medicinal reasons. These robber bee attacks are really, really upsetting and can be really detrimental um, to stingless bee farming. So they will often choose to cut down Lestramilita lemau nests in order
Hmm.
to make sure they preserve their own stingless bee colonies. Um, so yeah, they're a big problem. They're a big problem. Let's just say that.
The native communities obviously treasure these bees and their honey. Tell us a bit about their honey. Are they got any special properties?
Yes. So stingless bee honey has antibacterial, anti-inflammatory, wound healing, sunburn healing, and even neuroprotective properties,
Wow.
which is currently what's being researched. So they seem to have a lot of antioxidants and phenolic acids, which can reduce inflammation in certain areas of the brain And these antibacterial properties are really good because they kill off any nasties. So really useful for healing wounds. And stingless bees, of course, exist in a very hot environment that's very humid, and their honey is traditionally much more watery. So for this reason, they just need to have more antimicrobials and antibacterials to prevent the colonization of nasty microbes in their honey. But what's really interesting is in indigenous communities, they really rely on stingless bee honeys to treat eye problems like cataracts or conjunctivitis, which is a eye infection basically.
Yeah.
And they use it for intestinal and digestive issues and even reproductive or fertility help. So it's a really interesting area to be in because more research is needed to be done to essentially catch scientific knowledge up with indigenous knowledge. And I have a co-worker who is out in Peru living with indigenous communities there, and she has relayed all of this information to me as to why stingless bee honey is so important to them. So yeah, it's very different to regular honey because it's much more acidic, has a much lower pH, and it's more fermented because of this high moisture content. And yeah, that's all because stingless bees, as I said, live in much more tropical climates where the humidity is much higher.
Yeah.
So yeah, the honey is very different over here. It's got a different color, different composition, and lots of different properties than just our familiar honey that we're accustomed to back in the UK.
And how would you describe its taste?
So I've only had Scaptotrigona bipunctata honey, but that was really orangey and very acidic. Is a different flavor because you're expecting something very sweet, and then when it's very runny and very orangey, it kind of tastes a bit like marmalade in a way. But yeah, it's really interesting. I have to say, I couldn't imagine putting it on my toast in the morning. But it's probably too precious for that anyway. You need to save it.
Yeah, it sounds
Save it
it.
for the
Yeah.
infections. Save it for reproductive purposes.
Has it made its way into conventional medicine in Brazil?
I don't think so. I don't think so. I think the indigenous communities are very, very much ahead of where we are when it comes to
Mhm.
understanding and managing stingless bees. So yeah, it's going to take the scientific community a little bit more research to catch up and understand how brilliant stingless bee honey might be.
Fantastic. So you've come from the University of Bristol to the University in Sao Paulo. And how much longer have you got to stay?
So today is my last day.
Oh, no.
Yeah. But I'm really happy that I came. I have to say, meeting the different species of stingless bee out here and meeting people who've worked with stingless bees their whole life and have their own meliponaries at home has been really inspiring. And I've learned so much over this last month that I just could never have learned from books alone. Um, yeah, I've been attacked by bees. I've been stung by every mosquito in the book and bitten by everything. And I've even had my phone die due to the severe temperatures out in Brazil and had to buy a new one in the middle of an experiment. So it's all gone on this month, but I'm really happy that I came. Everyone has been very welcoming in Brazil as well. So yes, I'll be back. I'll be back.
And will you be able to produce a paper out of this?
Thanks to my lab assistant out here, Bruno Mateus Gomez. I think so. Bruno has essentially helped me with carrying all the equipment to the sites, marking the bees, filming them, and with his help, we've been able to do 160 plus trials, which should be some significant values out of that. So yeah, I'm really hoping that I'll be able to produce a really thorough examination of floral constancy and plebea, and hopefully set up some research questions for next year, because I observed some really unusual things going on. Um, I have to say the bees were much better at counting than I expected them to be. So sometimes I would provide the plebeia bee with the table of 12, and she would choose to not return at all. But the moment that I put out one single flower with sugar water on, just to retrain another bee, she would come back. So I had the feeling that they were very good at counting and they were able to associate 12 flowers means no reward, whereas one flower means lots of reward. So
Oh,
they were outsmarting me at times, and I had to just consistently find new colonies that were naive to what I was doing because they were catching up with me. So next year, maybe I could do an experiment looking at counting in stingless bees and how their association between the number of flowers and reward is working. Because yeah, they were very wise to what I was doing by the end.
what are you going to do once you get back to Bristol?
Oh, once I get back to Bristol, I will just sleep for a few days. And then it's time to think about what bumblebee and honeybee experiments I'm gonna do this year. But I'll have a little bit of a relax. I've got time to eat an Easter egg now because I came to Brazil over the entirety of March and the beginning of April, so I need to eat an Easter egg. And then once I've done that, I can start to think about my next set of experiments for the summer.
We look forward to hearing the results of this work, maybe in due course. Once you put it in the scientific paper, we would love to get a summary of it and to keep in touch about the work that you're doing in the UK. Look forward to seeing you sometime in Bristol, maybe at the
Cool.
Pollination Day
Yes,
that
I'll see
Bristol
you at the
has every.
Pollination Festival. That would be great.
When is that this year?
I'll be there and my whole lab group will be there. So if you want to ask any questions about bees and stingless bees, you know where to find us. We'll be at the University of Bristol Botanical Gardens on the 5th and the 6th of September. So come along, drink some mead, and learn some stuff about bees.
Right, I'm putting it in my diary immediately. Thank you
Yes.
very much, Kate. I'll see you there, if not before.
All right. Thank you very much. Thank you for having
Thanks.
me. I'll see you
Right,
very
bye.
soon.
Bye.
Bye.